Welcome to Unit 9, Lesson 3, the natural logarithmic function. Last unit we explored exponential form as well as logarithmic functions, and we also looked at the natural exponential form y is equal to e to the power of x. So we just want to take a few minutes and consider what that looks like in terms of logarithmic function and just discuss it so that if it comes up, you know what to do. So the reciprocal of the exponential function y is equal to e to the x is y is equal to log ex. The natural log function is generally expressed in the form y equals ln x, where ln is the abbreviation for natural logarithm. Thus, x equals e to the power of y and y equals ln x are equivalent. And as above, we just get the graph from making a reflection over the line y equals x. So it's just a reciprocal function, just like the last section of this unit. So it's got some properties. The domain is x is greater than 0. The range is all y values. It's an increasing function. The curve opens to the bottom. It's 1-to-1 proportion. So ln x1 equals ln x2, and therefore x1 equals x2. If x is less than 0, for 0 is less than x is less than 1, then the natural log of 1 equals 0, and ln x is greater than 0 for x is greater than 1. And we have a vertical asymptote at x equals 0. So just two examples there. We have the two graphs. There's graph 1 and graph 2, and the explanation for them is down below. So I've graphed them for you. You can just plot them. I guess they're plotted for you already. And the information about each of the questions is at the bottom there. So f of x is equal to ln of negative x. Remember, that will affect the x values. It's going to reflect them over the y-axis. So our domain is negative infinity to 0. Our range is all y values, and our asymptote is x is equal to 0. In part B, we have h of x is equal to 1 over the natural log of x. So we're creating kind of two asymptotes here. 0 would be included in the function, but we'll have a vertical asymptote at x equals 1. So you can see that there's an asymptote here. And we still have values between 0 and 1, so you need to plot those. And you'll get a little piece of the graph going downwards between 0 and 1, and then the remaining graph will be on the other side of the asymptote. Applying some of the laws of logarithms, they're actually coming up in the next unit, but we'll talk about it briefly right now. So you're given this question to expand the natural log of x squared times y cubed divided by the root of z. So all we're doing is just simplifying it and breaking apart the terms. So natural log of x squared plus, remember when we're multiplying, it's the same as adding the two logs together. The natural log of y cubed, and then dividing means to subtract, and a square root symbol is to the power of 1/2. So we'll get minus the natural log of z to the power of 1/2. And then these exponents that are here in the brackets, they can actually be pulled out and brought to the front of your logarithmic expression. So they're just moving down here. So we have 2 times the natural log of x plus 3 times the natural log of y minus 1/2 times the natural log of z. And more on that in the next lesson. The other thing you might be asked to do is to write as a single logarithm. So what we're doing here is combining all the terms. This one, natural log of x plus 1, it doesn't have anything done to it yet, so you just leave it alone. And this one, natural log of x plus 3, remember, just like in the previous example here, this value moved down to here. So we can take this coefficient 3 and make it our exponent. We'll have natural log of x plus 3 cubed, and then minus, remember this 1/2 is our exponent. It means to take the square root. It's x squared plus 2 to the power of 1 square root. So we're subtracting here, so minus the natural log of the root of x squared plus 2. And then we're just having a common base at this point. It's all in natural logarithm. Now all the terms are in the same format. They're all in natural log. So we can combine these terms. Remember that plus can be combined using the laws to multiply these two terms together, and then subtraction means to divide. So we'll get the natural log of x plus 1 times x plus 3 cubed divided by the square root of x squared plus 2. Beyond this, you have some practice questions, and you can prepare those before class tomorrow. Cha, cha, cha. Cha, cha, cha.